Hello, good morning, everybody. Welcome to our math class today. Today, I'm going to discuss with you on lesson 6.2, and this is about the similarity of polygons. In the previous lesson, we have talked that in a polygon, similar polygons have proportional sides. They have the same shape, but their size differs, but they have proportional sides. Let's start with reciting today's memory verse. And it's found in Genesis 1, verse 27. It says, "So God created man in his own image. In the image of God, he created them. Male and female, he created them." For your MVCA boosters today, it is about being like Jesus. Two polygons may not be the same in size, but they can still be similar in shape. We may not be as big as Bible heroes, but we can be like Jesus as they were. You write 3 ways that you can do for you to be like Jesus. At the end of today's class, you'll be able to do 2 things. First, illustrate similarity of figures, and second, solve problems that involve similarity. And here's your venture activity. You see this floor plan on your right? What is your strategy? What is the house's total lot area and the area of its rooms given the scale of 0.5 centimeters is to 1 meter? Now let's talk about similar polygons. 2 things, 2 common words that we will hear today: congruent and similar. In geometry, 2 figures are congruent if they have the same size and the same shape. For example, let me draw 2 squares. The first square has a measure of 4 in each of its sides. The other also measures 4 in each of its sides. If 2 figures have the same size and the same shape, like they are both squares and both have a 4 unit measure in each side, then we call them congruent. In congruent figures, their corresponding angles and sides are equal. So the sides are all equal, the angles are all equal. However, if figures have the same shape but may differ in size, or we say they have proportional size, then we call them similar figures. For example, a square has 4 in each of its sides. Another one measures 6 in each of its sides. You see, they have the same shape, right? They're both squares, and their sides are not the same, but they are proportional, like 4:6. So we call these 2 similar figures. This symbol is read as is similar to when we compare geometric figures. So we say, but when we use to compare sequences, this is to say is proportional to. Now, how do we define similar polygons? In similar polygons, corresponding angles are congruent. It means their angles are equal, while corresponding sides are proportional. Let's go back to my figure a while ago in 2 similar squares. Their angles are all equal. It measures 90 degrees each, while their sides are proportional. 4:6, 4:6, 4:6, and 4:6. Now, Here are examples of similar polygons. A small triangle and a big triangle, a small pentagon and a big pentagon, and two rectangles. While these are examples of dissimilar polygons, they have different shapes, right? Different shapes, same shape, but the sides are not proportional and the angles are not equal. So they are not similar. Now let's define a scale factor. I told you a while ago that in the square, the ratio is 4:6, right? That 4:6 is called the scale factor. Now, the common ratio of the lengths of corresponding sides of similar polygons is called the scale factor. Or we could say, we could reduce it. The scale factor is 2:3. Or that can be 3:2. It depends on which triangle you refer first. Now, when two polygons are similar, their perimeters will also have a ratio. The ratio of the perimeters is equal to the ratio of the corresponding sides. Or we say that the ratio of the perimeters is equal to the scale factor. Let's go back to the squares I've drawn a while ago with 4 in each side, the other with 6. The scale factor is 4:6 or 2:3. Now, if you solve for the perimeter, the sum of all sides, that's 4 times 4 sides, that's 16. And the other one, 6 times 4 sides, that's 24. If you check the ratio of their perimeters, that is still 2:3 or 2/3. Just the same with a scale factor. Now let us have these exercises. The first one, ABCD and UVWX are similar quadrilaterals. Let's name the corresponding angles. Base here. The first one, angle A and angle U. The second point, angle B and angle V. The third, angle C and angle W. And the last, angle D and angle X. For the sides, we can do it this way. First two, side AB and side UV. This one and this. Next, BC and VW. The next one, last two letters, CD and WX. And the last, we have AD and UX. So these are the corresponding sides and corresponding angles. Let's check the scale factor. You can just take one side. Like example, AB is proportional to UV. AB measures 8, while UV measures 16. We'll reduce it. The scale factor is 1:2 or 1/2. Next, let's go to letter C. We solve the perimeter of each quadrilateral. So for example, this is a rectangle. So you have 8 on the other side, 12 on the other side, 16 on the other side, and 24 on the other side. So we add all of the angles. If we add them, the perimeter is 40. How about the other one? If we add them, the perimeter is 80. Now the last question. We find the ratio of the perimeters of quadrilaterals ABCD and UVWX. That's 40/80 the ratio is still 1/2. Just the same with the scale factor that we had a while ago. Any questions? Feel free to message me in Telegram. Now, let's go to the next one. The first is we name the corresponding angles and corresponding sides. Let's name the corresponding angles first. The first and the first, that's how we write it. Angle K and angle C. The next, second and second, angle Y and angle A. The next one, angle U and angle R. Then the last is angle T and angle E. How about for the sides? Side KY is similar to side CA. KY, this one, and CA. I'll just make that as my side, okay? It means they are proportional. Next, YU is proportional to AR. So YU and AR. The next one, UT is similar to RE. So UT 3. And the last is KT is similar to CE. 1, 2, 3, 4. 1, 2, 3, 4. The next, we find the scale factor. You just find one pair of sides that are proportional and they have given measures. So if you see these sides, right? So the scale factor will be 10/24. Or that's going divided both by 2. That's 5/12. That's the scale factor. Let's go to letter C. But before that, let me first write the scale factor. It's 5/12. Let's go to letter C. We're looking for the measure of KT, right? So first is you write its proportional sides, its similar side. KT over, over CE. That is equal to the scale factor, 5/12. So KT is missing, CE measures 15, was 5/12. Cross multiply, so 12 KT equals 5 times 15. Divide both by 12. Our KT is equal to 5 times 15. Divide it both by 12. The measure is, that's 75 divided by 12. That will be 6.25. So this measures 6.25. Wait first. Now, if you check, you can divide it. 6.25 divided by 15, you'll still get with the answer 5/12, which is our scale factor. Next, let's find the measure of KY, this one. Again, you write KY and its proportional side, CA. That's equal to the scale factor, 5/12. So KY is missing, CA is 16, equals 5/12. Let's cross multiply. 12 times KY equals 5 times 16. Divide both by 12. We have 5 times 16, that's 80. Divide it both by 12. The answer is 20/3. So this measures 20/3. over 3. Next, what's the next one? YU. We write the proportional sides, YU and AR over AR is equal to the scale factor, 5 over 12. That's why U over 12 is equal to 5 over 12. Let's cross multiply. We have 12 YU equals 5 times 12. We divide both sides by 12. There. So YU is equal to 5. If you check, the scale factor is 5 over 12. So that's it for letter C. Now, for letter D, we solve the perimeter of each quadrilateral. So we simply add them. The first one, if you'll add them all of the sides, you'll get 27 and 11 over 12. For the other side, if you'll add all of them, you'll get 67. We find the ratio of the perimeters. If you divide 27 and 11 over 12 by 67, it will give you an answer of 5 over 12, which is equal to our scale factor. If you have questions, feel free to message me in Telegram. Now, let's go to exercise number 3. In one of the promotions of a car company, a model car is built with a scale of 1:15. This is our scale factor. If the model is 15.5 inches long, what is the length of the actual car? Now, what's missing? The length of the actual car. So we say, let X be the length of the actual car. Now let's write it. The length of the model, that's 15.5 inches over the length of the actual car, is equal to its scale factor, 1/16. We're looking for X. Let's cross multiply. That's X times 1 equals 15.5 inches times 16. So X is equal to 15.5 times 16. The answer is 248 inches. So the length of the actual car is 248 inches. Let's go to problem number 4, the last problem. A quadrilateral has sides 6, 10, 18, and x cm. A similar quadrilateral has corresponding sides A, B, 9, and 12 cm. Find the value of A, B, and x. Now you see that there are corresponding sides. These two are corresponding sides. These two are corresponding sides. These two and the last two. So we can write them in fractions. We have 6 over A. And remember, they are proportional. So they're equal to 10 over B, to 18 over 9, and to x over 12. You look at one complete pair. That's 18 over 9. So it means that the scale factor is 2 over 1, or 2:1. Now let's solve for the value of A. That's going to be 6 over A equals the scale factor, 2:1. We cross multiply them. We'll get 2A equals 6 times 1. Divide both by 2. Our A is equal to 3. Next, let's go to B. 10 over B equals 2 over 1. We cross multiply. Divide both by 2. So our B is equal to 5. Let's go to X. X over 12 equals 2 over 1. We cross multiply. Our X is equal to 24. And please don't forget the unit of measure, cm, cm, and cm. If you have questions, feel free to message me in Telegram, and hope you've understood our lesson for today. This ends our lesson, and have a great day, everybody. Bye-bye.